and Fusion handout. So some information for you to read. And then there's some questions we have to do. So we have something called Einstein's formula, E equals mc squared, which we've all heard before. So energy is equal to mass times the speed of light squared. So we're taking mass and we're turning it into energy. So energy is directly related to mass. So a nuclear device released this much energy. What mass was converted into energy? So here we have our energy and we want to know mass. Well, we know the speed of light, so we're just going to have to take energy, divide it by the speed of light squared, and that will give us the mass. Okay? So E equals mc squared, E divided by c squared equals m. So we're putting in our value here. Remember, a joule is a kilogram meters squared per second squared. We divide that by meters per second all squared. We're left just with kilograms. Okay, so we get 1.89 when we do this calculation. Kids often forget to square the speed of light. We get 1.89 times 10 to the negative 3 kilograms, or I converted that to 18.9 grams. So just 18.9 grams released all of that energy. So tons of potential. A kilogram of coal can produce this many joules of energy using combustion. How much energy can complete fission of a mass of 1 kilogram of uranium-235? So we have our mass, and I want to know the amount of energy. And then we're going to compare that to coal. So E equals mc squared. I'm going to put my mass in. I'm going to square the speed of light, and I get 9 times 10 to the 16 joules. Well, 9 times 10 to the 16, comparing that to coal, I get this many times bigger. 307, 087, 58, 14. I did that incorrectly. Let's look here. I think that's 3 million, isn't it? Or billion. So this would be millions. Yeah, we get 3 times 10 to the 9 times more energy from 1 kilogram of uranium. So that speaks a little bit about the power that is in uranium, in nuclear power, and why it is such an attractive source of energy. Something to think about in 2014, these are some mines in Saskatchewan and how many tons of uranium they were able to produce in 2014. So a total of over 9,000 tons. Each ton is 1,000 kilograms. And if you look at only 1 kilogram producing this much energy, that's a ton of energy that we are able to produce in Saskatchewan.